Hello everyone, welcome to this next question on complex analysis. This question is from GATE 2012 and it is of 2 marks. The question says, if we are given this integral is equal to 4 pi, then the closed curve C is defined by this triangle which have vertices at the point iota, -1 minus iota by square root 2 and 1 minus iota by square root 2. So here I have drawn this closed curve C here in the form of this triangle, right? So first point is given to be iota. So in complex plane, if this represents the imaginary axis and this represents the real axis, then the point iota would be somewhere here 0, 1, and then the point this number -1 by square root 2 minus iota by square root 2. This is defined using this number, right? -1 by 2 into and the point -1 by square root 2, right? So this point is the point B and it would be somewhere here. The value of this 1 by square root 2 is nearly equal to 0.7 something, right? So it would be less than 1. And similarly, this point is defined over here. So I have created this closed contour C, and the orientation is given to be in the anti-clockwise direction. So they are asking what is the value of this A out of these 4. So A is present over here. So that means in order to find the value of the variable A, we have to solve this integral and equate whatever is the result equal to 4 pi in order to obtain the value of A. So let us get started. Firstly, we have, in order to solve this integral, firstly what we'll do, we'll see if the given integrands, are they analytic inside and on the given curve C or not. If that is so, then we'll say the given integral is equivalent to 0. So this is the very well known theorem that we already know. So here let us check the points where we could have possible problems, right? So here you can check in the denominator we have to perform integration over this function 1 upon z minus 2 raised to power 4 minus a minus 2 raised to power 2 divided by z and plus 4. So here the problematic point, they can either be this point z. If you substitute z minus 2 is equal to 0, you will get z is equal to 2 and the power of this thing is 4. So that means you could have a possible problematic point at the point z is equal to 2. But you see our closed contour C is defined by this triangle ABC, and the point z is equal to 2 that lies outside this curve C, it would be somewhere here. So this is not a problematic point. So we can say this function 1 upon z minus 2 raised to power 4, that is an analytic function, right? So another point that could create a problem would be z is equal to 0. Now this point z is equal to 0 obviously lies inside our region C. So this is the pole and it is having order 1. Therefore, we can regard this to be the simple pole present at the point z is equal to 0 and this lies inside C. So in order to solve this integral, we have to apply the Cauchy's integral formula. So let us write the functions. So we can separate the integral. So it would be 1 upon z minus 2 raised to power 4 dz and then minus integration over C, then a minus 2 whole square divided by z, and then plus 4 integration, 4 could be brought out of this integral 1 into dz. So now here this function is analytic, this function is also analytic, 1 being constant, it is differentiable everywhere, right? So the integral over the closed curve C defined in the figure, that would be 0, and here also it would be 0. So we have to find the integral of this term. And what would be that? Here, if you suppose this function to be f of z, then using the Cauchy's integral formula, it would be 2 pi iota multiplied by the value of the function evaluated at the problematic point z is equal to 0. So it would simply be minus 2 pi iota, and the value of f when evaluated at the point 0, it would simply be a minus 2 whole square because there is no z here. So in the question, this whole integral is given to be equal to 4 pi. So if this is equal to 4 pi, that means we can equate this thing to be equal to 4 pi, right? So from here, we have to evaluate the value of a. So what would be that? We can cancel this pi term over here, and we can also divide this. So we'll be having minus iota multiplied by a minus 2 square, that would be equal to 2. So from here we have to evaluate what is a. So let us go one by one. So firstly we'll check for option A. In option A we are given a to be the point 1 plus iota. So if we substitute, say this is our expression star, if we substitute in the left hand side of star this value, we would have minus iota, and a is 1 plus iota, right? And minus 2 as such, then the whole square. Let us evaluate it. What would it be? It would be minus 1 plus iota whole square. So we can simply open up the square. So it would be 1 minus 1, right? Minus 1 square would be 1, plus iota square would be minus 1, and then minus 2 1 into iota, right? And this would simply be 2 iota square, that would be minus 2. So here this is not equal to 2. So which is not equal to right hand side. So this option is incorrect. Let us go and check for second option. For second option we would have a is equal to 2 plus iota. So the left hand side would then become, left hand side would be minus iota multiplied by what is the value of a? It is 2 plus iota minus 2 whole square, right? So here this terms cancel with this. Iota square would be minus 1. So we'll be having iota, and which is clearly not equal to 2 right hand side. So this option is also incorrect. Let us go for third option. The third option is 3 plus iota. A is equal to 3 plus iota. So our left hand side now becomes minus iota multiplied by the value of a, 3 plus iota, minus 2 whole square. So now this would be minus iota, and then here we would have 1 plus iota, and solving this we would have 1, the square of 1 is 1, the square of iota is minus 1, and then we would have plus 2 iota, right? So this cancels with this. So we are only left with minus 2 iota square, and iota square is minus 1. So we are only left with 2. Now this matches with the right hand side in the equation star. So this is equivalent to right hand side of star. So we can conclude from here that the value of a is equal to 3 plus iota gives you the correct answer. So from here we conclude that option C from over here, that is the correct option. I hope you understood the question. Well, that is it for this video. Thank you for watching.